Hi everyone. Today we're gonna start chapter 6. So I hope that you have watched my Calculus 1 first week video about the common curves. So they're on my Calculus 1 website, the first week. Okay, so part A and part B. So mainly focus on the part B. And then I discuss the common graphs for linear functions, polynomials, power functions, rational functions, and trig functions, exponential function, and logarithmic functions. So I hope you watch those videos. So for this graph of common functions, we need to memorize and understand them. Okay, because we will use them a lot in this chapter. So section 6.1, velocity and net change. Big idea. Given an equation for the acceleration, integrating the equation once leads to an equation for the velocity, and integrating a second time leads to an equation for the position. Big skills. You should be able to calculate projectile motion problems and some net change problems. So we call in Calculus 1, where we're given displacement and we take the derivative of the displacement to find velocity, and we take the derivative of the velocity to find acceleration. But right now, we are doing kind of the opposites. We are given acceleration. We integrate the acceleration to find the velocity. We integrate the velocity to find the displacement. However, remember, when you take the derivative, you only get a single function. But when you take the antiderivative, you get a family of functions. So you have the plus c at the end, remember? So you need to use the initial conditions, so initial velocity and initial displacement, to find the c, okay, to solve for c. So then we can find oops, sorry, I pressed the wrong button. To find the correct antiderivative from the family of antiderivatives. Okay, and the displacement on the time interval is gonna be the definite integral. Okay, the definite integral from A to B. And the distance traveled on the time interval is actually the definite integral of the absolute value of v of t. Okay, what's the difference between displacement and distance? Well, okay, suppose we have, let's say, v of t is like that, okay? And we want to find the displacement, let's say, from 0 to 5. Okay, what do we get? Well, if the velocity is above the t-axis, then the area we integrate is gonna be positive, right? If for the area for the parts, the function that is below the t-axis, this area is gonna be negative. Well, when you calculate the displacement, it's actually like the net area. You use the positive area, subtract the area below the t-axis, then we get the net area. However, for the distance, we want to calculate the total area. So this is like the net area. The distance is like the total area. How do you find the total area? Well, first of all, you need to find the x-intercept. Sorry, the t-intercept. Okay, so we need to find the t-intercept. Okay. And then, okay, you need to figure out, okay, you need to know what the velocity look like. When it's above the t-axis, when it's below the t-axis. When the function is below the t-axis, we want to have this area to be positive, so we flip it over to make it positive. Okay, so that's why after you find the t-intercepts for each of the area, you want to see whether the area is positive, and then just add it. If the area is negative, then we subtract it. Okay, so our distance is gonna be when the v of t is positive. We're gonna add those parts. Okay, so we're gonna add those parts. Okay, but when the area is when the velocity is negative, you're gonna subtract. Okay, for example, let's say this is 1, let's say this is 4. Okay, then what is the interval from 0 to 5? Well, let me just use this example. Okay, so the integral from distance from 0 to 5 is actually the interval from 0 to 1, because the v of t is going to be positive, and then subtract interval from 1 to 4, because here the v of t is going to be negative, so the area is negative, so you put a minus sign in front of it to make it positive, plus the interval from 4 to 5 v of t dt. Okay, so that is the distance. We will see more example, and we will calculate the distance later. But the idea is, if the area is above, just add it. If the area is below, you need to subtract to make it positive. Okay? So that's why in order to find the distance, you actually need to sketch the graph of the velocity function. You need to know where the velocity is positive and where the velocity is negative. Okay, so let's continue. So a particle moves in a straight line and has acceleration given by 2t. Its initial velocity is v of 0 equals minus 4, and its initial displacement is 2. Part A, find its position function s of t. So v of t is integral of a of t dt. A of t is 2t. Integral of 2t is t squared plus c, right? And how do we find c? Well, we have the initial velocity, which is minus 4. So when we plug in t is 0, we get 0 plus c. Oh, so c equals minus 4. Be careful. Some of you might think, oh, why don't we just let c be the initial velocity? Not always. This is only true when you work with polynomial. You actually need to plug in, okay? So you actually need to plug in. You cannot automatically assume that c is going to be initial velocity. This is not true, especially when you see the exponential function and the cosine function. Well, this guy, when you plug in t is 0, you don't get 0. Here, we get 0 because we're working with polynomial. We plug in t is 0, we get 0. But when you work with exponential function and cosine, you don't get 0. So you actually need to plug in and then to find the c. You cannot automatically think c is the initial velocity. So far, so good. So v of t is t squared minus 4. And then s of t is integral of v of t dt is integral t squared minus 4 dt. And what is that? Well, that's t cubed over 3 minus 4t plus, let's call it d, okay? And how do we solve for d? We plug in initial displacement, which is 2. So when we plug in it, so t is 0, so 0 minus 0 plus d, and we get d equals 2. So remember, you actually need to plug in. D is not automatically the initial displacement, so be careful with that. So s of t is then, d is 2, so t cubed over 3 minus 4t plus 2. This is part A. So far, so good, everybody. Part B, find the displacement on the time interval 0 to 3. Well, that from 0 to 3, that's actually the definite integral from 0 to 3 of v of t. But because we already find the antiderivative, so it's just t cubed over 3 minus 4t plus 2. Evaluate from 0 to 3. So we plug in 3 cubed is 27 over 3. 4 times 3 plus 2 minus when we plug in 0. But when we plug in 0, it's just like 0 plus 2. So 2 cancel. 27 over 3, that's 9. 9 minus 12 equals negative 3. So you can see the displacement on the time interval from 0 to 3 is negative 3, what's the units? Centimeter. So far, so good, everybody. And for my class, okay, if you forgot to write down the units, that's fine. But it's only for my class, okay? So if you are in your other class, like chemistry or physics or your major class, if the instructor asks you to write down the units, don't say, oh, Suki asked me, don't need to. No. It's only for my class, okay? Don't set me in trouble. Okay. So, part C, find the average velocity on the interval 0 to 3. So, average velocity equals change of displacement over change of time. So, that's s of 3 minus s of 0 over 3 minus 0. Oh, so we already calculate from part B. Change of displacements is negative 3 over 3, so it's minus 1 centimeter per second. This is the average velocity. So far, so good, everybody. And then part D. At what time during the interval 0, 3 is the particle at rest? Okay, so we are looking for the time. So we want to find the time such that the velocity is 0. Okay, velocity t squared minus 4, it equals 0. Okay, so I suggest you factor it because this works more general. I know you can move the 4 over and take the square root, but in general, if I give you a quadratic functions, equations, or I give you polynomial equations, how do you solve it? You also need to move all the terms to the left-hand side and factor it. And then this will give us t equals 2 or minus 2. But because here we're working with real-life problem, your t can only be positive. So that's why we only pick the 2. Okay, so the particle is at rest at 2 seconds. Part E, what is the total distance traveled by the particle during the time interval 0, 3? So this is the place you need to know. You need to sketch the graph of the velocity. Okay? So velocity, t squared minus 4. And we know it passed through negative 2 and 2, so, and it also passed through negative 4, right? So, oops. Okay, oops. Let me draw better. Okay, so this is velocity function. We want to find the distance from 0 to 3. We know this area is going to be negative and this area is going to be positive. So remember when we calculate distance, we want everything to be positive. We don't want the area to cancel out. For example, if we set the right hand side is the positive direction, if you go to the right 2 meters, and then you go to the left 4 meters. The displacement is negative 2, right? Okay, so the displacements tell you what is your position related to the starting point, origin, right? But if you're asking the distance travel, you go to the right 2 meters and you go to the left 4 meters, the total distance you travel is 6 meters. We don't want those 2 meters cancel out with each other, right? So that's why distance. In this case, we know the area from 0 to 2. We know this area is gonna be negative. So, okay, b of t is t squared minus 4. We know this area is gonna be negative, so we put a minus sign in front of it. We know the area from 2 to 3 is gonna be positive, then we add them. So for the areas that is below, add a minus sign in front of the definite integral. This is how we calculate distance. So far, so good, everybody? Let's continue. So t cubed over 3 minus 4t, it valid from 0 to 2. And this is t cubed over 3 minus 4t, it valid from 2 to 3. So here we plug in 2. 2 cubed, 8. 2 times 4, 8. When we plug in 0, it's just 0. And 3 cubed is 27. 27 over 3. That is 9 minus 12. And then minus when we plug in 2. When we plug in 2 is 8 over 3. And then also minus 8. So far, so good. You can see this one and this one, they are the same. They don't cancel out. Okay? So, that will give us minus 2 copies. So 16 over 3 and then plus 2 copy of 8, which is 16. 9 minus 12 is negative 3. Okay, 16 minus 3 is 13. 13 is like 39 over 3, right? Minus 16. Well, that's 23 over 3. So this is the distance. Okay, and distance is centimeter. So far, so good, everybody? See, when I'm calculating, I try to avoid calculator. So I hope you also practice calculating without a calculator. Cheers! I know you can do it. It might take more time, but it worth it. Okay, this is calculus 2. You still have more and more math classes and science class you need to take. Okay, example 2. A ball is thrown upward with a speed of 48 feet per second from the edge of a cliff 432 feet above the ground. Find its height above the ground t seconds later. When does it reach the maximum height? What is the maximum height? When does it hit the ground? Okay, so let's draw a picture. So we have a cliff. And we throw the ball. Right? So the ball's initial velocity, let's say the upward is the positive direction. Initial velocity is 48 feet per second. Initial displacement is, what's the height of the cliff? 432 feet. Okay, so this guy is 432 feet. Alright, so we're on the Earth. We have the attraction from the Earth. That's the gravity force, right? The acceleration due to gravity is 9.8 meter per second square. Is also 32 feet per second square. It's actually 32.2, but because we want to make it easier to calculate, so let's just use 32 instead of 32.2. So, and because we said the upward direction is the positive direction, so acceleration is going to be negative 32. So far, so good, everybody? And then velocity is the integral of acceleration. So integral of negative 32 dt is negative 32 t plus c. When we plug in the initial velocity, we get c. And c is 48 because we're working with polynomial. But be careful, your c is not always the initial velocity. Okay, so and then my v of t is negative 32t plus 48. And then s of t is integral of v of t, so negative 32t plus 48 dt. Negative 32t is t squared. Okay, 32 divided by 2, so 16t squared plus 48t plus d. And to find D, we plug in the initial displacement. But we just get 0 plus D. So D is 432. And then S of T is negative 16T squared plus 48T plus D is 432. So this is the height above the ground T seconds later. Okay, that is my first question. The second question, when does it reach the maximum height? What is the maximum height? When does it hit the ground? Okay, so what is special when it reaches the maximum height? What happened to the velocity? 0, and we're asking when. So we want to find the time such that velocity equals 0. So negative 32t plus 48 is 0. We can add 32t on both sides. We get 48 is 32t. We'll divide it by 32 on both sides. Do you see the common factor is 16? So when we cancel that, we get t is 3/2. Okay, try not to use your calculator. Build up the sense with the numbers. Okay. Next, so second, right? And then what is the maximum height? Oh, maximum height means we're gonna plug this time 3/2 into our displacement function. So it'll be negative 16 t squared, so 3/2 squared plus 48 t, which is 3/2 plus 432. Okay, let's see what it is. 3 squared 9, 2 squared 4, 4, 16 cancel, we get 4, and 4 and 48, sorry, 2 and 48 cancel, we get 24, 24 times 3, 72, plus 432. And 4 times 9 is minus 36. So, you know, 72 is like 2 copies of 36. So there's 72 minus 36, you get 36. Then 36 plus 432 is 468 feet. So far, so good. So this is the highest, the maximum height. And when does it hit the ground? What is special when it hit the ground? The height is 0, right? So we want to find the t such that the height is 0. So minus 16t squared plus 48t plus 432 equals 0. Okay, let's try to solve for t. Do you see 16 is a common factor? Actually, it is. Okay, and I also want to make the coefficient to be positive. So let's divide it by negative 16 for all the terms. Then I have t squared. 48 divided by 16 is 3. How about 432 divided by 16? We have 2. 2 times 16, 32. 112. 7. 7 times 6, 42. 7 times 1, 7. 7 plus 4, 11. See? So this is 20. Oh, sorry. It's negative. Okay, can we factor this guy? Oops. Can we factor this guy? Not really. The factors of 27 is 127, 9, and 3. So it won't give us the 3 in the middle. So we need quadratic formula. So what's quadratic formula? If you don't remember, let me remind you here. So quadratic formula is 2a, oops, and minus b plus or minus b squared minus 4ac. Okay, so that is the quadratic formula. And right now, we have 2a. 2a is, a is 1, so 2a is 2. Negative b, b is 3. Plus or minus b squared, 9. Minus 4ac, 4a is 1, c is negative, so make it positive, 27. So 4 times 27 is, so 108, right? So, and then 108 plus 9. 108 plus 9 is 117. Okay, so let's see. All right. Okay, so that's 3 plus square root of 117 over 2. So far, so good? So, and because we're dealing with real life problems, so we can only pick positive time, right? And 3 and square root of 117, which one is bigger? Of course, square root of 117, because 3 is square root of 9. 9, of course, less than square root of 117. That's why we only pick the positive one. We don't pick the negative one, because the time can only be positive. So this is the time that's 8 heat to ground. So you can leave your answer like this, or you are allowed to plug in your calculator right here. So if you want to find a decimals, let's do that. So this is 3 plus square root 117 and divided by 2. So this is approximately equals 6.9083 seconds. Okay, so that's our answer. Okay, I want to ask you one more questions. So what if I want to find, let's say I want to find the velocity when it hits the ground. Okay, so I want to find the velocity when the stones hit the ground. What do? We plug this time into our velocity function. Okay, so that is t squared minus 4. Okay, I know the answer is going to be negative because the stone go up. So we know this is going to be a negative number. Okay, so here, yeah, I allowed you to use your calculator here. So this guy squared minus 4. I see. Okay. Let's see. Velocity. Oops, sorry. My velocity. I used the velocity of my previous problem. So the velocity here is negative 32t plus 48. Negative 32. Negative 30. Oops. Negative 32t plus 48, right? Let me double check. Yes, negative 32t plus 48. So let's try again. Negative 32 times that number plus 48. I got approximately negative 173.066. Okay, and the unit is feet per second. And it's pointing down, that's why it's negative. And that finished our problem. So far, so good, everybody. Okay, let's continue. So the good thing about the video is you can pause at the steps and think more and control the pace. Okay. So let's look at example 3. A block hangs at rest from a massless spring at the origin, vertically. At time equals 0 second, the block is pulled downwards 0.25 meters to its initial position, okay, and release. Its velocity is given by v of t equals 1/4 sine t for t greater equals 0. Assume that the outward direction is positive. Find the position of the block for t greater equals 0. So we have a block, right, attached to a spring, and let's say this is at equilibrium position. Okay, and then what do? We're gonna pull the block 0.25 meters down and release. Okay, so because the outward direction is positive direction, we pull down the block, so S of 0 is negative 0.25, and because we release, so v of 0 is 0, the initial velocity is 0, and we have v of t equals 1/4 sine t, and which makes sense because when we plug in t is 0, sine 0 is 0, initial velocity is 0, so it makes sense. Okay, so find the position. Okay, how do we find the position? Well, S of t is we integrate the velocity function. Don't forget to include the dt. So many students in my previous semester, they remember to write the integral sign on the left, but they forgot to write the dt. Okay, they come together. Don't forget it. And what is the integral of sine? Oh, it's cosine, but plus or minus. But then think about the derivative of cosine is minus sine. So the integral of sine is minus cosine. Okay, and what is our, let's see, what is our initial, so to find the constancy, we plug in the initial displacement. So S of 0 is minus 0.25, is actually 1/4. And when you plug in 0, oh, cosine 0 is actually 1. Ooh, you see, C is actually 0 in this case. So S of t is minus 1/4 cosine t. That is part A. Okay. And also, you need to show your work for finding the C, okay? So sometimes students forget to write plus C. In this case, if a student forget to write plus C, then he will get the right answer. But in the exams, you need to show your work. You need to show your work to include the plus C and then plug in and to show me the C is 0. Otherwise, you will lose points because, and then I just assume you forgot to plus C when you integrate. Okay? So show all your work in order to receive full credits. Okay, so part B, when does the block move through the origin for the first time? So move through the origin. What does that mean? What does that mean? S is 0, right? So let's look at this guy. So we have minus 1/4 cosine t is 0. So, well, that's the same as cosine t is 0. So cosine graph. See, I asked you to be familiar with the common graph. So what's the graph of cosine? It's oscillating and it starts from 1. So it's oscillating like that. Huh? Okay, so this is 2 pi, and this is pi over 2. So when is the first time it passed through the origin? At pi over 2. Okay, this is the first time it passed through the origin. So far, so good. Okay, next. When does the block reach its highest point for the first time? What is the position at that time? When does the block return to the lowest point? Okay, So when we're talking about highest points, lowest points, what is special about it? So it's at the highest points or the lowest points. Okay. We know that the velocity is 0. So we look at the velocity function. So that's 1/4 sine t is 0. Okay, so what's sine t? Oh, by the way, this is cosine t. So sine t start from 0 and oscillating, right? So at zero is actually our initial position, okay? And then next, what's the next angle? Make it 0. Oh, that's pi. So t is 0, pi, 2 pi, and 3 pi, etc. Right? And, well, this 0. Okay. Well, this 0 is the initial position, right? Initial, we start with t is 0. So the initial position is s of 0 equals -1/4, right? At pi, what is the position at pi? So s of pi is -1/4 of cosine pi. Well, cosine pi, what's cosine pi? Okay, here. Cosine pi is -1. So -1/4 times -1 is 1/4. So at pi, we get 1/4. 1/4 is actually the highest point. Okay, so it actually reached the highest point for the first time. Okay, and then how about 2 pi? At 2 pi, so at 2 pi, s of 2 pi is actually because -1/4 of cosine 2 pi. Cosine 2 pi is 1, so you get -1/4. So this is at the lowest point again. Okay, so this is the position return to the lowest points when time equals 2 pi. So the block return to the lowest points. Okay, then you know at 3 pi it reached the highest point for the second time, and then etc. So far so good, everybody. So that is example 3. So in general, we not only can work with the one-dimensional motion, acceleration, velocity, and displacements. In general, we can have a quantity Q of t, such as volume or population size. Then we can talk about the rates of change. Okay, when we're talking about the population, then is the growth rate, right? Then the net change is gonna be the definite integrals of the rate of change, okay? And what is the future value? The future value is you integrate the rate of change. Okay, let's look at example 4. A culture of cells in the lab has population of 100 cells when nutrients are added at a time t equals 0. Suppose the population n of t increases at a rate given by n prime of t is 90 e to the 0.1 t minus 2 t to the 5th cells per hour. Find the populations for t greater equals 0. What is the population after 1 day? Okay. So n of t is integral of n prime of t dt, right? And so integral of 90 e to the 0.1 t minus 2 t to the 5th dt. Okay, so constant multiples stay there. E to the 0.1 t is still e to the 0.1 t, but when you integrate, what do? You divide it by 0.1, right? Minus, okay, 2 stay here, t to the 6 over 6 plus c. And do you know what is 1 over 0.1? That's 10, right? So this is 90 times 10, 900. E to the 0.1t minus 1/3 t to the 6 plus c. So this is the integral, okay? And next, we want to solve for c, but we have information. We have the initial population is 100. So we plug in t is 0. E to the 0 is 1, so we have 900. T to the 6 is 0 plus c. Oh, what happened with the c? C is actually C is actually 100 minus let me see. Okay, so C is negative 800. So far so good, everybody? All right, so let's see what's next. Okay, so then n of t is gonna be 900 e to the 0.1t minus 1/3 t to the 6. And then c is minus 800. So far so good, everybody? Okay, and then what is the population after 1 day? Well, is this n of 1? Is this n of 1? Be careful, our units is hours. So 1 day is how many hours? 24 hours. You gotta be careful. So sometimes if the unit is days, then you plug in 1. If the unit is hours, then you need to think of, okay, how many hours in a day? It's 24 hours. So we plug in 24. So we get 900 e to the 0.1 times 24 is 2.4 minus, this is 24 to the 6 and minus 800. Okay, of course, this one we can plug it in our calculator. I won't ask you to calculate by hand, okay? So let's plug in e to the 2.4 minus 24 to the 6 divided by 3 minus 800. Oops. Okay, I think there's something wrong with my my problem. Okay, so let's flip the sign. Okay, so let's make this guy negative, and let's change this guy to positive, because yeah, I think I make a mistake when I make up this problem. So this should be oh sorry, let me see. Oh, sorry. Okay. The negative is not there. Okay, where is my... Okay, so the... Oops. So the negative should be here. Okay, so how will this change to our problem? So this is negative... Oops. Okay, so okay, so okay, so all right, so this will change this to negative, and then when we integrate, this is negative, we make this negative. So this is negative, this is negative, this is negative. So C will be 1,000. And so this is plus C will be 1,000. Okay, and this is negative, this is negative. Okay, and this is negative. This is negative. And sorry, this is positive, this is positive, this is positive, this is positive, positive. And this will be positive. Okay, let's try again. I don't want to get a negative numbers. I need to change the problem because I got a negative number, which does not make sense, right? So let's do it again. Negative and e to the minus 2.4 and plus 24 to the 6 over 3 and plus 1,000. Oh, okay. Now I get a positive number. Okay, good. So my answer is 6370191.35 approximately. Okay, so this is our answer. Oh, but because we're working with cell, it's better to have integer, right? So we cannot have half of a cell. Okay, so this is our answer of this problem. So far, so good? So I'm sorry at the end I need to change the problem because I changed my worksheet last semester. We have a easier function, so I want to increase the difficulty a little bit, so I changed the function a little bit to make it more interesting. So okay. So, but anyway, it works a similar way, and our final answer should get a positive numbers. Okay? And that's it for today. So today we talk about applications, and we did the one-dimensional motions, acceleration, velocity, displacements, but we also talk about the distance. For when you work with the distance, you have to be careful. You need to sketch the velocity and find the t-intercept and understand when the velocity is positive, when the velocity is negative, so that you can split the integral. Okay? And we also see the examples with this population. Okay, so actually any quantity, if you're given with the rate of change, you can always integrate it, and then you can find the quantity by integrating the rate of change. Okay, and that's it for today. Have a nice day. Bye.